right, we've spent 3 days working on radical functions, and now we're going to spend 3 days working on rational functions. And the parent function for a rational function is y equals 1 over x. And in here there's the blue graph of the function y equals 1 over x. If you will, there is an asymptote here at y equals 0. Right. This blue line never touches, it gets real close, but never touches the line y equals 0. There's also an asymptote at x equals 0. These two blue lines will get really, really close, but will never touch the line x equals 0. Which means that the domain is all of the real numbers except x is not equal to 0. And the range is all the real numbers except y is not equal to 0. Now, as we move through, this is the general form or general format for a rational function. Y equals a over x minus h plus k. And this hk point is going to be this central point, right, about which the figure is drawn. All right, we'll look at that as we get a little further along. So, what happens when we throw a negative sign in there? And of course, it doesn't matter whether that negative sign is out front, whether it's in the numerator or it's in the denominator, it's all the same. And instead of being this blue function, instead of being graphed in the first and the third quadrants, y equals negative 1 over x will be graphed in the second and fourth quadrants. The domain is still, because there's an asymptote at x equals 0, the domain is still x not equal to 0. And there's an asymptote at y equals 0. And so for the range, it's all the reals except for y not equal to 0. Now for changing the numbers, multiplying and dividing, I guess, if you will. Again, the blue 1 over x is our parent function, and when we add a number or multiply by a number larger than 1, right, this point gets further and further away from your center point. Right? In other words, here's with the blue, and that's the parent function, so if I multiply, I get bigger, and it moves further away from, in this case, 0, 0 in both cases. And then if I multiply by 1/5 or divide by 5, it makes this distance smaller in between where this line loops here, and it gets as close as it can to this center point, and it does it for this side here and the side here. And as we've seen before, if you change the number on the outside, it moves things up or down. In this case, minus 4 brought the center location from 0, 0 down to 0, negative 4. Right? If you were drawing this asymptotes would be at x equals 0 and at y equals negative 4. And you get that from the negative 4 there. And that means the domain is everything but this is x equals 0. The range is everything except y not equal to negative 4. They're asymptotes at x equals 0 and at y equals negative 4. Compared to when a number is added or subtracted underneath the fraction bar, or inside, as we like to say. Well, in this case, it's going to be a movement of 3 to the left. If you remember, this is x minus h, so it's the opposite of what you think. And so this center point at 0, 0 has now moved to negative 3, 0. Asymptotes at x equals negative 3 and at y equals 0, which means the domain is all the reals except for x is not equal to negative 3. The range is all the reals except y is not equal to 0. So, if I gave you the equation y equals 1 over x minus 2 plus 3, and I ask you to graph that, the first important point to figure out is where is the center of this action going to be occurring. It's not really the center, but where is it all centering around? And that is going to be at 2, 3. And you get that from the inside or underneath and the outside. So that means we're going to have a vertical asymptote at x equals 2. And you can see I've dotted that line. And you're going to have a horizontal asymptote at y equals 3, and that's that dotted line. And then I knew, since it wasn't being multiplied by anything, that it had to go through this point here and this point here. And from there, it's just a sketch. Right? I get it really, really close to this asymptote and come in, hit that point, and make it really, really close to this asymptote. Same thing here, start really, really close to the asymptote, come, make sure it goes through that point, and then really, really close to that asymptote. And really, we're only looking for a sketch at this point would be perfect.